So this is kind of finishing up some just topics in chapter 13 in terms of solutions. So we've talked about electrolytes before. Electrolyte is something that conducts. So we did this especially first year chemistry, sticking a conductivity meter into a solution and the light bulb goes on is considered an electrolyte. Non-electrolyte is something that does not conduct electricity. So to be more specific, you are going to have to distinguish between what we call strong versus weak electrolytes. Strong electrolytes are things that completely dissociate when dissolved. So that would mean they have a Weierhoff factor, something greater than 1. And we are mostly dealing with what we call ionic salts or soluble salts. And in that grouping of strong electrolytes will be your 6 strong acids and your and your strong bases, the ones that are in column 1A and column 2A on the periodic table, those hydroxides. So mostly the solutions we are dealing with in here are going to be considered strong electrolytes, so that would mean the light bulb shines very brightly compared to something weakly electrolyte. That's going to be with a small degree of dissociation, so the I would be a greater than 1, but it would not be substantially as big as you would have with a strong electrolyte. So small degree of dissociation, so some of it breaks up. Those are your weak acids and weak bases, which we will be discussing further on in our lecture this semester. So the 2 big ones that you need to remember are acetic acid, is a weak electrolyte, and ammonia, NH3, is also considered to be a weak electrolyte. Then if you have another category called the non-electrolytes, these are things that don't dissociate. So their I is essentially equal to 1. So these are molecular compounds, so sucrose, glucose, ethanol, anything with carbon, at least from me, is going to be considered a non-electrolyte. So that would mean the light bulb doesn't go on at all. So strong, very bright, weak, slightly on, and then a non-electrolyte, no light bulb goes on whatsoever. All right, so some other discussions that the book talks about is different kinds of mixtures that you could find in chemistry. We mostly deal with solutions, but you could also have what we call colloids or suspensions. So solutions, you can't see the particles, they're so small, so they're invisible to the naked eye, while colloids are medium-sized particles, so they're a little more cloudy, and they exhibit what we call the Tyndall effect. And then suspensions are things with large particles. Mostly those are things that settle out. So if you think of a sample of river water or something like that, you take it, you let it settle, you will see larger particles fall to the bottom of that container. Now the Tyndall effect is something you can distinguish between a solution and a colloid, or a solution and a suspension. And then a suspension, you could just let it settle out. Please watch my video that I found. It's a really short video, a guy showing the Tyndall effect. It is when you shine a light through a solution, you see the scattering of the light. So think of a foggy night. As you are driving in your car, you see the beam of light because of the water particles. So that's the way you can distinguish between a solution, a colloid, and a suspension. All right, and then the book goes into something called distillation, and more specifically fractional distillation. So I have put a couple videos up for you. It is a way to separate liquids based on different boiling points. So the AP world has decided that you kind of need to know this procedure more so than you actually doing it, because the glassware is kind of expensive. So watch the videos on it, and especially the other one that is on petroleum. And I do have a diagram for you in your notes about that. So that is how we take the crude oil and separate it into all of the different components that we use on a daily basis. So that's the petroleum diagram that I'm talking about, and the video goes through that. And then this other video is what we call laboratory distillation, where you take a mixture in a round bottom flask and heat it, and you when it goes and boils off and it condenses through this condensing tube, you could then what we call fractionally distill it. So you could take different samples of it and figure out which liquid came out first from that. And then finally, to wrap it all up, I know there's a lot of stuff going on in this video, is to make a solution. And I have pointed, I've also given another video on solutions that I found. Either you're making it from a solid or you're making it from a liquid. If you're making it from a solid, you're going to mass it out and put it into something called a volumetric flask we've talked about before. And the reason you use this is because the solid takes up volume. So when you dump it into water, you can't say, oh, I'm going to put it all into 1 liter, because the solid will take up some of the volume. So that's why it is very useful to use a volumetric flask if you want to have the exact volume of your solution. If I'm just making up a solution, I don't need to know the exact concentration. I could just throw it into a beaker, that's fine. But volumetric flasks are going to be very key in making a solution correctly. And then liquids, because it is a liquid, you're going to use M1V1, and we've used that before. And you're going to be using a volumetric pipette to essentially dispense it into a volumetric flask. So please watch the video. It's a very straightforward video to kind of show you the volumetric flask and the pipettes, so that you are familiar with that in terms of equipment.